Today we're studying polynomial functions in Chapter 2. First and foremost, a polynomial function is nothing more than a string of x terms. You've seen them all last year, or not all last year, but all back in middle school. A polynomial function, for example, is 3x squared plus x minus 2. So a basic quadratic function, or even a linear expression. Those are polynomials. They're just a string of x's. We could also take a cubic. So all those are polynomial functions. The advantage of a polynomial function is that it's continuous and beautiful in every way. So even in BC calculus, we take messy curves and try to write them as polynomials in order to make it easier to work with. So our goal in this chapter is to take these polynomial functions and analyze them and see why they're so beautiful and why they may be useful later on. In general, the way we write a polynomial function is a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus, and we basically just count down until there's no term. This term here is our constant term, just like up here, up here, and up here. And you can see our x term right there. It's our linear term, our quadratic term, our cubic term would be next, and so forth. This one's important. That states the degree of a polynomial. So for example, this first one would be a degree 2 polynomial function. This one would be a degree 1, and this would be a degree 3. It's simply the highest exponent or highest power that we're being raised to. The big thing we want to do in this chapter is find the zeros or the roots. The zeros of the roots are nothing more than x-intercepts. These are two different names for x-intercepts. So let's do a couple problems where we just find the zeros of the roots of a function. Let's let our first function be f of x is equal to 2x cubed minus 32x. Again, it's a polynomial function because it's a string of x's with a degree 3. So we want to find the x-intercept, so we set it equal to 0. We let y equal 0. This one we can factor. We can pull out a 2 and pull out an x, and be left with x squared minus 16, which is a difference of squares. So if we factor it like we did last year, you can see that these answers here are x equals 0, x equals 4, and negative 4. And again, that was a basic problem from PST. Let's do one other problem. Let's let f of x equal 3x squared plus x minus 2. This is more difficult for you. It's a trinomial, but there's a constant coefficient. So you have to think back to your PST skills. And when you factor it, you have to use whatever method you learned last year. Some people just use guess and check. It factors down to 3x minus 2 and x plus 1. Therefore, our answer is x equals 2/3 and x equals negative 1. I do these two examples because factoring is probably the most important skill from algebra that you'll use in calculus and pre-calculus. Let's do one more before we switch gears. Let's let g of x equal 2x cubed minus 18x over x plus 3. First and foremost, you should recognize that this is not a polynomial function. It is actually called a rational function, which we'll study later on. And the reason why it's not polynomial is because you are dividing by some unknown, by some expression. So now, first and foremost, if you want to find the zeros, this would be equal to 0 if the top equals 0, because then you'd have 0 over the bottom. So you have 2x cubed minus 18x is equal to 0. If you pull out a 2 and an x, we have x squared minus 9, just like the first one we did today. And 2x times x plus 3 times x minus 3. So x equals 0, 3, and negative 3. The one problem with this is this bottom. This bottom tells us what x cannot be equal to. So from here, going back to last year when we worked a little bit with rational functions in PST in January, this should tell you that x cannot equal negative 3. If it did, you'd have 0 over 0, which is undefined. Therefore, negative 3 cannot work over here, and the answer, the zeros, are just 0 and 3. So the biggest part of finding the zeros of a function is basically factoring. So in this chapter, we're going to be dealing with much messier functions. So let's take a polynomial function, f of x is equal to 3x to the fourth. So degree 4 polynomial function. We would like to find the zeros of this function. Right now, that's going to be an impossible task. So first and foremost, we're going to review a method of dividing. So it's called synthetic division. Our ultimate goal is to find the zeros, but that'll take a couple days to be able to do. So if we want to synthetically divide, this is basically what we're doing. Let's find f of 4. You could plug it in, but synthetic division is actually easier, especially without a calculator. What we do is we put 4 over here, and we put the coefficients of the expression up on top. And then all we do is synthetically divide. We drop the first number down. You multiply on the outside, you add on the inside. So 4 times 3 is 12. Add them, you get 5. Do it again, multiply, you get 20. You get 15. 4 times 15 is 60. Add them, you get 69. 4 times 69 is 276. Add them, you get 286. That's all synthetic is. I'm leaving something out for a second. Let's do another one real quick. What if we said, let's plug in f of 1. So you put 1 there. Multiply, you get 3. Add, you get negative 4. Multiply, you get negative 4. Add, you get negative 9. Multiply, you get negative 9. Add, you get 0. Multiply, you get 0. Add, you get 10. What I'm leaving out is, how does that connect to this? We have here 1, 2, 3, 4, 5 numbers. But f of 4, if we plug in, we get one number answer. So what I would say to you for tonight is to plug in x equals 4 and x equals 1, and notice how synthetic division gives you the answer. So there's a little bit of a task for you to do real quick. It'll take you probably about 1 minute. Just use your calculator, plug it in, see how this is related to the answer, and then from there we can pick up tomorrow. Have a good night.